For this real 3 by 3 matrix, the eigenvalues are 1 plus I, 1 minus I, and 4. Gershgorin's theorem predicts where all 3 must live before solving the cubic. Each row draws one closed disk in the complex plane. The proof is only one eigenvector equation, viewed through its largest component. For row k, center the disk at akk and define our k as the sum of absolute akj over j not equal to k. Row 1 is centered at 1 with radius 1. Row 2 gives the same disk. Row 3 is centered at 4 with radius 0.3. Complex entries would use complex centers and the same absolute value rule. Take an eigenpair ax equals lambda x and choose k so absolute xk is maximal. Component k says lambda minus akk times xk equals the sum over j naught k of akjxj. Apply the triangle inequality. Since every absolute xj is at most absolute xk, the row sum rk completes the bound. Now solve this example exactly. Expanding along the third column factors the characteristic determinant as 4 minus lambda times quantity 1 minus lambda squared plus 1. The roots are 4 and 1 plus or minus I. The conjugate pair lies on the boundary of the disk centered at 1. For lies at the center of its isolated disk. The theorem has a counting refinement. A connected component of the union formed by m row disks contains exactly m eigenvalues, counting algebraic multiplicity. Here the two coincident disks at 1 form a two-disk component containing the conjugate pair. The isolated disk at 4 is a one-disk component, so it contains exactly one eigenvalue. Separation creates the count. Do not read the basic theorem as one eigenvalue per disk. 4b equals rows 1 minus 1 and 2 minus 1. The exact eigenvalues are plus and minus I. The first disk has center 1 and radius 1, and contains neither eigenvalue. The second has center minus 1 and radius 2, and contains both. Only union inclusion is guaranteed without separation. Draw row disks from each diagonal and deleted row sum. For any eigenpair, choose a largest component. The triangle inequality forces lambda into its disk. Separated components count eigenvalues, but disks do not give exact locations or one eigenvalue each. Our verifier checks 9 claims and 560 seeded complex eigenvalues.